The crossover method is a shortcut way of writing formulas for ionic compounds if you know the charges on the ions in the compound. We'll go over a few examples. In example A, we're asked to write the formula for magnesium chloride. Looking at magnesium on the ion table or periodic table, we see it's Mg with a charge of 2+, and chloride is Cl with a charge of minus or -1. We start the formula by writing down the symbols Mg and Cl. Now we take the 2 from the charge on the magnesium, cross over, and write it next to the chlorine. Now we could take the 1 from the charge on the chloride, cross it over, and write it next to the magnesium, but we don't use the subscript 1 in a formula, so we don't need to write anything. So the formula has 1 Mg and 2 Cls. So we'll compact it and write the final formula for magnesium chloride as MgCl2. We'll check the charges to verify that this formula is correct. We have 1 Mg2+ ion and 2 Cl- ions. So the total charge is +2 plus 2 times -1, or +2 plus -2, which is equal to 0. So the formula MgCl2 is correct. Example B asks us to write the formula for calcium oxide. We look up calcium and it's Ca with a charge of +2, and oxide is O with a charge of -2. We start the formula by writing down the symbols Ca and O. The charge on calcium is +2, so we cross over and write a 2 next to oxygen in the formula. The charge on oxide is -2, so we cross over and write a 2 next to calcium in the formula. Notice we always drop the negative when we write subscripts. Now we have the formula Ca2O2. But you can see that both of the subscripts in this formula are divisible by 2. So we simplify and divide both of these by 2 and get 1s. We do not keep the subscript 1 in a formula, so we remove the 1s, leaving us with the formula CaO, which we'll compact and write as the final formula for calcium oxide. Checking charges, we have 1 Ca2+ ion and 1 O2- ion. So the total charge is +2 plus -2, which is equal to 0. So this formula is correct. Question C asks us to write the formula for chromium 3 sulfide. The chromium 3 ion is Cr3+, and the sulfide ion is S2-. We start the formula with the symbols Cr and S. We take the 3 from the charge on the chromium, cross over, and write 3 next to sulfur in the formula. And we take the 2 from the 2- charge on the sulfide ion, cross over, and write 2 next to chromium in the formula. There is no number other than 1 that will divide into 2 and 3, so this formula cannot be simplified. So the final formula for chromium 3 sulfide is Cr2S3. Checking charges, we have 2 Cr3+ ions and 3 S2- ions. So the total charge is 2 times +3 plus 3 times -2, or +6 plus -6, which is equal to 0, so this formula is correct. Question D asks us to write the formula for palladium 4 oxide. Palladium 4 is Pd with a charge of 4+, and oxide is O with a 2- charge. We start the formula with the symbols Pd and O. We take the 4 from the charge on palladium, cross over, and write 4 next to oxygen in the formula. We take the 2 from the charge on the oxide ion, cross over, and write 2 next to palladium in the formula. Now we have the formula Pd2O4. But we see that both of the subscripts 2 and 4 are divisible by 2. So we simplify by dividing the 2 and the 4 both by 2, giving us 1 and 2. We remove the subscript 1, leaving us with the formula PdO2, which will compact and state as the final formula for palladium 4 oxide. Checking charges, we have 1 Pd4 plus ion and 2 O2 minus ions. So the total charge is positive 4 plus 2 times negative 2, or positive 4 plus negative 4, which is equal to 0. So PdO2 is the correct formula for palladium 4 oxide.